Ladies and gentlemen, welcome to our discussion about determining types of reactions. There are 5 types of reactions that you will have to know how to classify. In order to classify a reaction, we are going to consider 3 things. First, we're going to look at the numbers of reactants in products. You can have either 1 or 2 reactants and 1 or 2 products. Depending on how many you have, will help us give a hint to what type of reaction it is. Sometimes that will allow us to immediately identify its type. Other times we'll have to look for more information to distinguish between them. If I can't decide by numbers of reactants in products, then I'm going to start considering 2 and 3. Are there elements involved or compounds or both? And where are they in terms of the reactants or products? Lastly, I'm going to consider what pattern the change in matter follows. The names give us some hints as to what the matter will do, but I'm going to have to look at the arrangements of the atoms and how those arrangements change from beginning to end. Our first type of reaction is called synthesis. Synthesis is a word that means to make. So when we look at what's happening in this reaction, first I want you to notice that there are 2 reactants and 1 product. This particular reaction can typically be identified without proceeding past it, but let's check our other information to confirm. Both of the reactants are simpler forms of matter. And when they are combined together to make the product, we form a more complex substance. Now, in the case of the example, both of the calcium and the oxygen are elements. These are the simplest forms of matter that you can have, and they bond together to create a compound. There are examples of synthesis reactions where you have an element bonding to a compound or 2 compounds bonding together to create a more complex compound. But big picture, if what you start with is simpler and you have 2 of them and they bond to create 1 more complex product, you have a synthesis reaction because you've made this more complex product. Our next type of reaction is decomposition. You should think of breaking down. Decomposition is a term that is often used to describe the breakdown of living things. Think about like a tree decomposing in the woods after it falls down and dies. Here we have 1 reactant and 2 products. The reactant is complex, and relatively speaking, the products are more simple. You may have noticed a pattern. It is simply the opposite of synthesis. So when we look at synthesis and decomposition, they're simply more or less flip-flops of each other. Here, this little dot is indicating that all of this is 1 substance. So decomposition breaks it apart, and here we now have 2 less complex substances. This one is a little more like what you'll see commonly, where you have just a single compound that is there. And in this case, we got 2 less complex products. And in this case, we do have a compound and an element. I could get 2 elements, I could get 2 less complex compounds, but notice this one has 3 elements in it. This compound only has 2. So it is less complex. So synthesis and decomposition are opposites of each other, easy to determine by numbers of reactants and products. Single displacement or replacement is very similar to double replacement. The pattern of the idea of a switch occurring is the same, but what differs is what's switching. Notice here that you have an element reacting with a compound. And in both cases, I have two reactants and I have two products. So unlike synthesis and decomposition, which changes my number of reactants and products, here a change is happening within the substances. In the case of single displacement, the element trades places with one of the elements in the compound. So here we see that A and B traded places. The metal always comes first in a substance. That's why A is in the first position in the product. And here the non-metals trade places. So A is trading places with C. That's why A is in the second position, because that's where non-metals go. An example of this type of reaction would be something like Na plus HCl yielding NaCl plus H2, and then we would have to make sure it is balanced. Okay. Here the H is in the first position, so that's why it's trading places with the Na. So now the Na is in the compound and the H2 is by itself. A non-metal example, let's say I had Cl2, remember it's a Hofbrinkel, that's one of our diatomics, plus Li I. That would give us I2 plus LiCl. I would need 2 of these and 2 of these to balance the reaction. So the Cl traded places with the nonmetal, the iodine, and so then the iodine is now by itself and the Cl is in the compound. In double replacement, you have 2 compounds instead of an element and a compound, and both trade places. So notice here the H used to be with the Cl. Now the H is with the Br and the Cl is with the Mg. So the Mg and the H trade places so that they can be with the other option. These ones are almost the easiest ones to do, but it's really important to make sure you keep track of what the charges are. You'll notice that the charges stay the same on both sides of the arrow. Our last category of reaction is kind of the outlier. It's one of these things is not like the other. If it isn't synthesis, decomposition, double or single replacement, you are looking at a combustion reaction because it doesn't fit any of the other rules. You will have some compound with carbon and hydrogen, and sometimes oxygen. It will react with O2 only. That's the only option it could be. And it will always produce CO2 and water. So if you see O2 as a reactant and CO2 and water as the products, just simply confirm that you have C's and H's at least in your reactant and you have a combustion reaction. These will often also end up having really high coefficients because the compounds that are the fuel sources for combustion have really big molecular structures. So notice that we had C6H14. When you have that many atoms within a molecule, you're going to need a lot of oxygen to react with it, and many carbon dioxides and waters will be produced because those molecules are so small. It's not single replacement because I have 2 products. that are compounds. It's not double replacement because I have an element in the reactant. It's not synthesis or decomp because we have two reactants and two products. In order to be one of those, one side or the other has to have only one. So when in doubt, look for O2 reacting with C's and H's to give you CO2 and water, and you have combustion. Your next steps are you should start looking at your packets of work that you have or downloading the example problems and attempting to classify what type of reaction each one is. Please check the discussion posts or consider using my office hours to ask questions for help.